Namaskar, welcome to the very first lecture of complex integration. Yes, and when the integration of a complex valued function comes into our mind, it means we have to integrate the function like this, isn't it? But what are the things that we are going to discuss in this lecture? Let me let you know. First of all, we will discuss that which are the properties that can be carried out from रियल एनालिसिस और कैलकुलस, है ना. रियल से किन प्रॉपर्टीज को हम कैरी आउट कर सकते हैं उसको एज इट इज फॉलो करेंगे. ओके, सो दिस इज द फर्स्ट थिंग. सेकेंड थिंग, आई विल डिस्कस about the curves in the complex plane, because in real analysis or calculus we used to integrate over a particular interval, but in complex analysis we have to integrate over a contour. Okay, curves joining end to end, that is called contour. Okay, in this lecture I will also try to discuss what is the difference between the Jordan arc and Jordan curve. Okay, Jordan arc and closed curve, closed arc and Jordan curve, what are the differences? Everything will be discussed. I will also discuss the concept of winding number. So yes, in this lecture we will discuss these fundamental things for sure. But some natural questions comes into our mind, that if w is equals to u of t plus iota v of t is there, then how shall you get your w dash t? Yes, you people are saying, oh, it's so simple, u dash t plus iota v dash t. Similarly, okay, like in calculus, the derivative of sin x is cos x. In calculus, the derivative of sin z with respect to z will become cos z in complex analysis. But don't forget, sin x in calculus is bounded, but sin z in complex analysis is unbounded. Okay, in C. All right. So yes, there many things are similar, but we have to take care of some interesting things. I would also like to ask you one thing. All the properties, many properties of differentiations are going to be carried out. जो भी properties है उसको हम carry कर लेते हैं, मतलब जैसा कैलकुलस में वैसा कॉम्प्लेक्स एनालिसिस में भी. बट डू यू नो देयर आर सम प्रॉपर्टी दैट कैन नॉट बी कैरीड आउट फ्रॉम कैलकुलस. कुछ ऐसे प्रॉपर्टी है जिसको कि हम कैलकुलस से कैरी नहीं कर सकते. विच आर दोज? सो नाउ, एंड आई एम गोइंग टू राइट दैट इन रेड. यस, है ना, लाल कलम से लिखना चाहूंगा. मीन वैल्यू थ्योरम. मीन वैल्यू थ्योरम for derivatives. Mean value theorems for derivatives cannot be carried out. Cannot be carried out from calculus. Why and how? कैसे और क्यों? Because, for example, if we will take w of t a continuous function, counter example देना पड़ेगा ना. काउंटर एग्जाम्पल, इफ वी विल टेक अ कॉन्टिन्यूअस फंक्शन w of t is equals to u of t plus iota v of t, right? And let's take your t lies between a to b. All right, and let's take your w is continuous, and if your w is continuous, so certainly u of t will be continuous, v of t will be continuous for sure. Okay, so yes, in between a to b, your function w of t is continuous. And also let's take w dash t. This is the first case, Lagrange's mean value theorem. First case, w of t is equals to u of t plus iota v of t. It should be continuous in closed and bounded interval a b. Let's say w dash t exists in open interval a to b, These are the two conditions. Then according to Lagrange's theorem, there must exist a C between A and B such that W dash C is equals to W of B minus W of A upon B minus A, isn't it? But in complex analysis, there may not exist C in AB such that, कॉम्प्लेक्स एनालिसिस में कोई जरूरी नहीं है कि एक ऐसा सी ऐसा एग्जिस्ट करे कि W डैश C इज इक्वल्स टू W ऑफ B माइनस W ऑफ A अपॉन B माइनस A हो. ओके, what the thing is, there may not exist in complex analysis. In real analysis, if these two conditions are satisfied, this and this, then certainly there must exist a C between A and B such that this is going to happen, which is called mean value theorem. But in complex analysis, this facility may not available. For example, if I will give you W of t, okay, for example, if I will give you W of t is equals to e to the power iota t, and your t lies between 0 to 2 pi. Then to show there does not exist C in between 0 to 2 pi such that W dash C is equals to W of B minus W of A upon B minus A. So certainly we need to show it, isn't it? So now W dash C is the thing. So if we will find mod of W dash T, then what do you think? What the thing is going to be obtained? Mod e to the power iota t, and mod of e to the power iota t is 1. Okay, mod of e to the power iota t is what? Certainly it's 1. It's not 0. But if you will find W of pi minus W of 0, but W of pi minus W of 0 upon 2 pi minus 0, then what the thing you are going to get? E to the power 2 pi iota minus e to the power 0, just a second, minus e to the power 0 upon what? 2 pi. So 1 minus 1 will become what? 0. So finally you are going to get a 0. So in the RHS, WB minus WA upon B minus A, this is 0. But in LHS, W dash T ka mod is 1. So here is a contradiction. Okay, and therefore you can say that in complex analysis the mean value theorem was not valid. Okay, but this was for differentiation. This thing was for differentiation. Do you know one thing? When you need to find the integrals, then how shall you do? And similarly you can see that this mean value theorem for integrals is also not going to carried out from calculus, है ना? मीन वैल्यू थ्योरम फॉर इंटीग्रल्स के लिए भी वो कॉम्प्लेक्स एनालिसिस में ट्रू नहीं होता है. ओके, बट लेट्स इंट्रोड्यूस सम वेरी फंडामेंटल integrals in complex analysis. Okay, actually most of the integrals in complex analysis will look like this. Okay, over the contour C, f of z dz, you need to evaluate this. But think, if it is given from A to B, f of z dz, then how shall you work? Okay, for example, if I will give you this A to B 1 plus iota t whole square dt. Okay, certainly this is a complex integral. All right, and let's take A is equals to 0, B is equals to 1. For example, and then we will come to the contour. Okay, because certainly we are transforming ourselves from real to complex. So that's the reason we should go through with each and everything. So from 0 to 1, how do you do it? So 0 to 1, 1 square plus 2ab and plus ba square. Alright, dt. So finally you will do what? This is 0 to 1. You can see what is the thing right here? 1 minus ta square dt. And thereafter you will take iota as common and you are going to get 2t dt. Isn't it? Iota has taken as common and thereafter you can see the things beautifully. Now you have to integrate this real part, which is t minus t cube by 3 from 0 to 1 and plus iota into 2t square by 2 from 0 to 1. So finally what the things will happen, what the things you are going to get? Yes, it will become 1 minus 1 by 3, and for t is equals to 0 everything will be okay, you know, by putting upper and lower limit, and iota into 2 to 2 will be cancelled and t cube from 0 to 1, so certainly it will become 1. So finally you can say it is nothing but 2 by 3 plus iota. This will be your integral. Okay, but in real analysis most of the time we were doing integration on the segment of real number like a to b. But in complex integration we have to integrate over a contour. I mean to say the curves joining end to end. Okay, but the curves may be a Jordan arc, that might be a Jordan curve, that might be a closed curve. Alright, so what are those we'll discuss in detail, don't worry at all. But before coming to that, I would also like to say that mean value theorem for integrals, okay, one more note in red, that mean value theorems for integrals, mean value theorems for integrals is not carried out in complex analysis. Okay, many properties, many rules, okay, properties of definite integration, so all those are going to be carried out, but the mean value theorem cannot be. Why? What is the reason? Okay, so now let me show you with the example. Think if you have a complex valued function which is defined and continuous in t lies between a to b. All right, to show that it is not going to be carried out in complex analysis, मतलब complex analysis में mean value theorem true नहीं होगा, तो इसके लिए क्या show करना होगा? To show we will do what? There does not exist C in open interval AB. Okay, yes, it is continuous in A to B, it is differentiable in open interval AB, this is given. But if we will show that there does not exist any C in AB such that integration from A to B Wt dt is equals to W of C into B minus A. If we will show that this is going to happen, that there does not exist any C, you should be very careful with this. यहाँ पे आप careful रहिए. There does not exist any C such that this is going to happen, because if this will happen then we will say that mean value theorem is well and good, but here this is not going to happen, and for this we need to take an example. For example, you can take W of t is equals to, yes, the same example, e to the power iota t. Okay, and your t lies between 0 to 2 pi. Your t lies between 0 to 2 pi, certainly it is continuous. in this interval, it is differentiable in open 0 to 2 pi, differentiable in t lies between 0 to 2 pi. All right, yes, all these things are there. Okay, so now if you will try to find integration from a to b w of t dt, then you can see what, 0 to 2 pi e to the power iota t dt. Okay, so it will become e to the power iota t by I from 0 to 2 pi. All right, so e to the power iota 2 pi, so e to the power 2 pi I by I and minus e to the power 0 by iota. So you can see what, this is 1, this is 1 as well, so 1 minus 1 is going to become 0. But what the thing is going to happen, if you will try to find the RHS of this w of c into b minus a, then that will become non-zero. How shall you confirm this? If you will see the modulus of w of c into b minus a, so w of c means what, w of 2 pi. Okay, w of c means what, sorry, e to the power iota c. This is how your function is defined, e to the power iota c. It will become e to the power iota c. Okay, and into b minus a, so 2 pi minus 0. So finally you can see that this is going to become e to the power iota c into 2 pi. So this is what, 2 pi, right? So here in the RHS you are going to get 2 pi, in the LHS you are going to get 0. LHS and RHS are not equal, and it is enough to show that yes, the mean value theorem in complex analysis, in complex integration is not going to be carried out. I mean to say, mean value theorem is well and good for calculus and real analysis, but not good for complex analysis. Okay, so after these discussions, certainly we need to discuss what? Curves in complex plane. Curves in complex plane. Why do we need this? Actually, you need to find the integrals of f of z on this C, on this contour C, right? So yes, we are going to discuss curves in the complex plane. So how your curves looks? So let your gamma from this closed and bounded interval a to b to c defined for all t belongs to a to b, and your a to b is the subset of R. I mean to say, this a and b are the end of this curve, okay, and in parametric form we can write x of t, gamma of t is equals to x of t plus iota y of t. Okay, t is a parameter, will let you to know how it works. But before coming to that, let's go to discuss the types of the curve, okay, where these x of t and y of t are what? Real valued continuous functions. These are real valued continuous functions on AB. Okay, real valued continuous functions in AB. Okay, and this gamma is called what? Curve in the complex plane. Curve in the complex plane. But now, which kind of curve will be there? When shall you say that your curve is closed? When shall you say it is Jordan arc? When shall you say it is Jordan curve? Okay, all these things are going to be discussed. So if you have the curve gamma from AB to C, then it is called closed if your gamma of A is equals to gamma of B. Okay, but I will ask you some question and certainly you might get confused sometime. Okay, sometimes you will be able to see, oh, the curve is closed, then why I am not able to say. Many interesting questions are coming, don't worry. So closed if gamma of A is equals to gamma of B. Second, it is called Jordan arc or simple curve. Jordan arc or simple curve if your T1 is not equals to T2 implies gamma of T1 is not equals to gamma of T2. If this is going to happen, then you will say it is Jordan arc. Then you people say, oh, I did not understand geometrically. So when you will draw the curve and gamma is not intersecting on AB, gamma is not intersecting on AB, I mean to say in between A and B, gamma is not going to intersect itself again, then it is called Jordan arc or simple curve. Okay, with a lot of examples I am going to illustrate all these things, don't worry about that. And when shall you say your curve is Jordan curve? When shall you say your curve is Jordan curve? When it is a closed curve as well as it is a Jordan arc. So a curve which is Jordan arc and closed at the same time are called Jordan curve. Okay, so yes. So now I am going to ask you some questions. You have to say yes or no. No matter you are watching it recorded. If you have gamma from closed and bounded interval AB to C, okay, such that gamma of T is equals to cos T plus iota sin T. Alright, and certainly your T lies between A to B. Then if I am going to ask you about this curve one by one, okay, yes, I am going to take the interval, yes, 0 to pi for this curve. Then we'll discuss in 0 to 2 pi. All right, then we'll discuss everything in between 0 to 3 pi, and then we'll discuss everything for the interval 0 to 4 pi. Alright, and yes, the curve is same but in different interval. When shall you say it is, okay, let me make one more column. When shall you say it is a Jordan arc, or you will say closed curve, or you will say Jordan curve. Okay, let me give some numbering 1, 2, 3 and 4 so that I can figure out everything. Okay, so now the curve gamma of T, which is cos T plus iota sin T, will it be a Jordan arc between 0 to pi? So first of all, you will see this is what? This is nothing but gamma of T is equals to e to the power iota T. Its modulus is 1. So it's what? A unit circle. But if the domain is defined, so the first figure will become what? The figure number 1 will become what? Which kind of figure will be there? Certainly it will be the things like this. 0 to pi, upper half circle. Okay, now let's go to see everything. Will it be a Jordan arc? So what is the definition of Jordan arc? Okay, from 0 to pi, it should not intersect itself. So you can see this curve is not going to intersect itself from 0 to pi. So certainly it's a Jordan arc. But is it a closed curve? The answer is no. Why? Because for closed curve, gamma of 0 should be equals to gamma of pi. Okay, so gamma of pi will become what? Cos pi minus 1 sin pi 0. So it will become minus 1 and it will become what? Gamma of 0 1. So not equal. So it's not closed. And Jordan curve are what? A curve which is both Jordan arc and closed. Then we will say it's Jordan curve, which is not here because it's not a closed curve. Now if you will take 0 to 2 pi, then how your picture will look like? The picture will look like this. Okay. Then I am going to ask, is it a Jordan arc? The answer is yes. Why? Because between 0 to 2 pi, it is not going to intersect anywhere itself. Is it closed curve? The answer is yes. Why? Because gamma of 0 is equals to gamma of 2 pi. Because e to the power 2 pi and e to the power 0 are same. So it's closed curve. And being Jordan arc and closed curve, you shall say it's Jordan curve. Now, I am going to ask you about this. Okay? Yes, but your interval is 0 to 3 pi. So you have to complete one revolution and then you have to go again up till pi. So hence you can see from 0 to 2 pi, from 0 to pi, this curve is going to intersect itself and therefore it's not a Jordan arc. Will it be a closed curve? The answer is no. Why? Because you can easily see that gamma of 0 will become 1, but gamma of 3 pi is going to become minus 1. So whether, okay, intuitively you can see, oh, it's closed, but actually gamma of 0 is not equals to gamma of 3 pi, and that's the reason you shall say it is not going to be closed. And as it is neither Jordan arc nor Jordan curve, therefore nor closed curve, therefore it is not a Jordan curve as well. Now I am going to ask 0 to 4 pi. So how shall you figure out? So for 0 to 2 pi you can see the circle, but for 0 to 4 pi you can see it is going to repeat itself again. So 2 times this curve is going to repeat itself. So you can see from 0 to 2 pi this curve is going to overlap itself, therefore it is not a Jordan arc. But when you will find gamma of 0, then you will get gamma of 4 pi. Both are equal. E to the power iota 4 pi and e to the power 0, both are same, and therefore you will not hesitate to say yes, it's closed. But as it is not a Jordan arc, therefore you shall say it is not a Jordan curve. So hence this is a very beautiful diagram that a curve may be Jordan arc but neither closed nor Jordan curve. A curve may be all of these three: Jordan arc, closed curve and Jordan curve. A curve will be may be neither Jordan arc nor closed curve nor Jordan curve. Or a curve may be a closed curve but neither Jordan arc nor Jordan curve. Okay, so any curve may be of any kind, isn't it? Yes. Now we are going to discuss the length of the curve, but before coming to that, I am going to discuss the winding number of the curve, and in the next class we will discuss about the length of the curve and many integrations. So I would like to say that naturally, if I will say, or formally if I will say, that the complex integration will be started from the next class, but certainly this winding number is really important. So what is winding number and how you use to calculate it is really interesting to see. Okay, so what are winding number? So think, if your gamma is a closed curve, if your gamma is a closed curve, and let's say A belongs to C, not lying on gamma, this point is not lying on gamma. Okay, I mean to say it is either inside or outside, either inside or outside, then the winding number of gamma with respect to A is defined as number of times gamma revolves around Z is equals to A. Z is equals to A. Okay. number of times gamma revolves around z is equals to a. Okay, let me make a beautiful picture to illustrate it. Let's say here is a point A, all right, and let me make a picture. This is picture number 1, I mean to say curve number 1. Okay, the picture is like this, all right. So let's say this is point A and these are the curve in positive orientation, I mean to say counterclockwise. And if this is your point A, then what will be the winding number of this point A with respect to these curves? What would you like to say? You can see how many curves are there. 1, 2, 3 and 4. So winding number of the curve gamma with respect to this point A is 4, because 4 times the curve is going to revolve around it. If your point is over here, let's say B, then winding number of gamma with respect to B will become what? 0, because this point is outside the curve, then the winding number will become 0. Okay, I would like to say that if you will reverse the orientation, then what shall happen? Okay, if you will reverse the orientation, okay, I mean to say the winding number of minus gamma with respect to A will become what? Minus of winding number of gamma with respect to A. Reversal of curve will be discussed in the next class, don't worry. But this is how we used to calculate winding number. Okay, how many times it is going to revolve. If the sense will change, sense will become clockwise, then the sign will be negative. For example, if I will ask you that if you have gamma is equals to e to the power nit, and your t belongs to 0 to 2 pi and your n belongs to naturals, then if anybody is going to ask you the winding number of gamma with respect to 0, then what will be your answer? So hence you can visualize the picture that you have n is equals to 1. For n is equals to 1, it will be a circle like this. Okay, but for n is equals to 2, again you are going to get a revolution, complete revolution. For n is equals to 3, for n is equals to 4, again you are going to get the revolutions. So around 0 there are how many? N number of curves, so its winding number will be n. Similarly, if anybody will ask the question like this, gamma is equals to e to the power iota t, okay, but your t belongs to 0 to n pi, okay, 0 to 2n pi, and n belongs to n, then what would you like to say the winding number of this gamma with respect to 0? Then your answer will be n again, isn't it? Why? Because you can see that here is n, so 0 to 2 pi, 0 to 4 pi, 0 to 6 pi, things like this. So again this 0 will be surrounded by n number of curves in anti-clockwise sense, so certainly its winding number will be n. So naturally in the next class we will start complex integration on contour, because when these curves or arcs are going to be joined end to end, then it is called a contour. Okay, so certainly we will discuss all these things in the upcoming class. Till then, take care, bye bye, thank you very much. If this lecture really helped you, then certainly you can share and you can subscribe this channel. You can also put your comments with your suggestions without any hesitation. So certainly we shall meet in the next class. Till then, take care, bye bye, thank you very much everyone.